Question 4. Complete table 2 to show the initial rate of reaction of P in each experiment. So we've got experiment 1, that's done. We need to do experiment 2. So we're given these values, right? To find out the initial rate, all we're going to do is the change in concentration divided by time. So for this one, for experiment 2, is going to be 2.00 times by 10 to the power minus 2 minus 1.84 times by 10 to the power minus 2 divided by 5. This for experiment 2. And we get 3.2 times by 10 to the power minus 4. And for the experiment 3, same thing, 0.50 times by 10 to the power minus 2 minus 0.30 times 10 to the power minus 2 divided by 5. Again, we get 3.2 times by 10 to the power minus 4. Okay, and then part 4.2. 4.2 says determine the rate of reaction with respect to P and the order of reaction with respect to Q. So we know this is the initial rate of reaction of P in each experiment. So what it is gonna be is P is gonna be well, if you look here, P doubles, but Q stays the same. So the order of reaction with respect to P is going to be 1. And order with respect to Q, well, if we look at this, yeah, because from experiment 1 to experiment 1 and 3, if we look from here to here and here to here, this we times it by half. 1.0 times by 10 to the power minus 2 times by half, you get 5 times by 10 to, no, actually 0.50 times by 10 to the power minus 2 divided by 1.0 times by 10 to the power minus 2, 0.50 divided by 1.00 a half, 1.0 times by 10 to the power minus 2 times by half, yeah, 0.50 times by 10 to the power minus 3. So we're timesing by a half here, here we're timesing by 2, right? And we know to get from experiment 1 to 3, we double it. So this is 2, this is a half. Well, what's 2 times a half? Well, that's 1, obviously. So therefore Q must be to the power of 2, because this must be squared then. Because therefore 4 times by half is 2, and that's what happens to rate of reaction, doubles. So therefore Q must be 2. So P is equal to 1, Q is equal to 2. And then the final part, question 4. So, the reaction between substances R and S was second order with respect to R and second order with respect to S. So let's write that down. Rate equals K, second order with respect to R, second order with respect to S. We're trying to find a rate constant K, or K is equal to rate divided by R squared S squared. We know that the initial rate of reaction was that. So we know the initial rate of reaction is 1.2. Then we get to value of a value of K as 9992, which is equal to what? 1.99 times by 10 to the power 1, 2, 3, 4. And the units, probably the hardest part of the question. Well, the units is going to be mole per dm minus cube s to the power minus 1 all over mole per dm minus cube to the power of 4. That cancels out. We're left with s to the power minus 1 over mole to dm minus cube to the power 3, which is mole to the power 3 dm to the power minus 9. But because the denominator, we're going to do the opposite, so it's going to be mole to the power minus 3 dm to the power 9 s to the power of minus 1. So for question 4, this bit of applying, you can find out the, actually this bit, yeah, just find out change in concentration divided by time. This bit, just look at them and then eventually compare the values, look at the initial rate, doubles, and then you find out P is equal to 1 or with respect to P, Q is equal to 2. This one we know this was second order with respect to R, second order with respect to S. Rate is equal to K R squared S squared. Rearrange it to get K. K is equal to R divided by R squared. K is equal to rate divided by R squared S squared. Substitute the values in given in the question. Get this, put it in standard form and the units as that, and that is the end of question 4.